City lights in space? James Webb Telescope sparks new debate on alien life. In a groundbreaking revelation, NASA's James Webb Space Telescope, JWST, has detected what appears to be artificial lighting, akin to city lights, emanating from Proxima Centauri b, an exoplanet located approximately 7 trillion miles from Earth. This extraordinary observation has reignited global curiosity about the potential existence of extraterrestrial life. Proxima Centauri b, the closest known exoplanet to Earth, has long been a focal point for astronomers. The JWST recently zoomed in on the planet and recorded bright, unusual lights radiating from its surface, specifically from the night side. The nature of these lights, reminiscent of urban illumination, has scientists both amazed and perplexed. Could this be the first real sign of an intelligent alien civilization? For decades, both the scientific community and the public have speculated about life beyond our solar system. Any shred of evidence has been met with enthusiasm. And now, this sighting by the JWST may be the most compelling clue yet. The possibility that these city lights are artificial raises profound questions. Have they been shining for eons, waiting for Earth to evolve the tools to detect them? David Kipping, an astrophysicist at Columbia University, has called Proxima b a particularly intriguing target. Unlike typical rocky planets, Proxima b exhibits unique thermal patterns and infrared characteristics that diverge significantly from those of its host star, Proxima Centauri. JWST's advanced infrared imaging plays a crucial role here. Its sensitivity enables it to detect even the faintest light signals in deep space, making it an ideal instrument to study the atmospheric and surface conditions of exoplanets. On Proxima b's night side, even minor artificial lighting could be observed if it falls within a specific frequency band, much narrower than the starlight reflects. Interestingly, Proxima b appears to receive significant solar energy on its day side, possibly harnessed through vast solar panel rays. During its 11.2-day orbit, the planet experiences day and night cycles similar to Earth's. Without an atmosphere, this would result in extreme temperature shifts between its sunlit and dark sides. If an atmosphere is indeed present, it could moderate these fluctuations and make the planet more hospitable, perhaps even habitable. Scientists are now working to determine if Proxima b has an atmosphere rich in life-signifying gases like oxygen, methane, or water vapor. Detecting these elements requires careful analysis of how light passes through the planet's atmosphere, an extraordinarily challenging task, even for JWST. Still, JWST has limitations. While powerful, it can only focus on nearby exoplanets in detail. To push the boundaries further, researchers are looking forward to the extremely large telescope, YELT, scheduled to begin operations in 2028. The YELT, a ground-based observatory, is expected to deliver unprecedented data about the composition and potential habitability of distant worlds. In the meantime, JWST continues to be humanity's most advanced eye on the universe, revealing clues that could redefine our understanding of life in the cosmos. Future missions aim to block out overwhelming starlight, using large shields or internal masks, allowing telescopes to detect the much fainter light reflected from exoplanets. This technique could revolutionize how we observe planetary atmospheres and detect signs of life. One key challenge, however, is distinguishing biological activity from non-biological sources, like volcanoes. Astrobiologists are developing sophisticated methods to tell the difference, so false positives don't derail the search. Despite decades of effort, no confirmed signs of life have yet been found. Still, the dream persists. Are we alone in the universe? That question continues to drive exploration, inspire innovation, and fuel missions like those conducted by JWST. Even as new evidence emerges, projects like SETI, Search for Extraterrestrial Intelligence, founded in 1984 by Jill Tarter and Thomas Pearson, continue scanning the skies using radio telescopes such as the Allen Telescope Array. Because radio waves can travel vast distances without scattering, they remain one of the most promising tools in the hunt for alien civilizations. As humanity stands on the brink of potential cosmic discovery, the possibility that intelligent beings may be quietly watching from afar feels more real than ever. The universe may be whispering its secrets. We just have to learn how to listen. For over 30 years, the SETI Institute has meticulously monitored radio transmissions for signs of alien life, but without success. Despite this, SETI pioneer Jill Tarter remains optimistic, expressing her hope that one day, people around the world will play a role in the ultimate search for extraterrestrial intelligence. This long-running quest took a dramatic turn recently when NASA reported that the James Webb Space Telescope, JWST, may have detected what appear to be city lights on a nearby exoplanet. As humanity's most advanced tool for probing the universe, JWST represents a giant leap in our ability to explore the cosmos. Launched in December 2020, the telescope is widely regarded as the most powerful infrared imaging instrument ever built. Its sophisticated optical technologies allow it to peer through cosmic dust and unlock some of the universe's oldest secrets, including the formation of the first galaxies and stars billions of years ago. Named after visionary NASA Administrator James E. Webb, who was instrumental in the Apollo moon missions, the telescope is outfitted with state-of-the-art instruments: a near-infrared camera, an IR-CAM, a near-infrared spectrograph, an IR-SPEC, a mid-infrared instrument, MIRI, and a fine guidance sensor, FGS, that ensures its pinpoint accuracy. At the heart of the JWST is its iconic mirror, composed of 18 hexagonal segments engineered to capture faint light from the earliest corners of the universe. It operates at extremely low temperatures, enabling it to detect even the weakest heat signatures from distant celestial bodies. Since its launch, JWST has sent back breathtaking images and critical data, deepening our understanding of exoplanets, galaxies, and distant stars. But its latest observation, possible artificial lights emanating from Proxima Centauri b, one of the nearest known exoplanets to Earth, has ignited intense debate within the scientific community. The detection of these mysterious lights has led researchers to reconsider the likelihood of intelligent life elsewhere in the cosmos. Some scientists believe the patterns and intensity of the emissions suggest they could be artificial rather than natural. This has fueled speculation that the lights might originate from an advanced alien civilization, or possibly from bioluminescent organisms producing light in an unfamiliar way. If the lights are indeed artificial, it would challenge current assumptions about the boundaries of life in the universe. However, not all researchers agree. Others theorize that the lights could result from unknown natural phenomena, such as rare atmospheric processes triggered by Proxima Centauri b's volatile climate or interactions with its host star. Factors like magnetic fields, radiation belts, and exotic atmospheric chemistry could create visual effects that mimic city lights to JWST sensors. For now, the true nature of these emissions remains a mystery. Upcoming observations will focus on whether the lights change over time and if they follow any regular patterns. JWST's long-term monitoring capabilities are expected to provide crucial insights into whether the emissions remain constant or fluctuate in ways that suggest artificial activity. As this extraordinary discovery unfolds, it brings humanity one step closer to answering one of the most profound questions of all. Are we alone in the universe? Long-term monitoring of potential electrical grids or other forms of artificial infrastructure is essential, as it may uncover further clues that lead to groundbreaking insights. As technological capabilities continue to evolve, scientists are expected to develop even more advanced tools and techniques for studying exoplanets. Upcoming space missions and cutting-edge observatories, such as the extremely large telescope YLT, will enhance our ability to detect signals and gather data beyond what the James Webb Space Telescope, JWST, can achieve alone. These instruments, working in tandem, will create a powerful network for space exploration that may ultimately confirm the existence of extraterrestrial life, or at the very least, deepen our understanding of distant worlds and their potential to support life. The idea of detecting intelligent life through artificial lights on exoplanets has opened an exciting new frontier in the search for life beyond Earth. Although we have yet to definitively prove that alien civilizations exist, each discovery, be it a faint signal, an unusual light emission, or an unexplained anomaly, brings us closer to answering one of humanity's most enduring questions. The implications are profound, touching science, philosophy, and society. Learning that we are not alone in the universe could radically alter how we perceive ourselves and our place in the cosmos. Should these findings point to the presence of advanced civilizations, it could usher in a transformative era, one marked by the exchange of knowledge, culture, and perhaps even technology, reshaping the course of human history.